replacing with something, or especially something of the same kind or newer substances will be joined with the other. So that we can call as change. So here, what are the changes said? Here, change is said to be replaced with something else, or especially something of the same kind or a newer substance will be added to another compound here. They are called as here changes. Here, in our day-to-day life, just you can raise your hand to unmute yourself. You don't have option to unmute. Okay. Now the topic is classification of changes. So here, how to classify the changes here? In our day-to-day life, we can observe the changes. Maybe the changes in its color or its shape or its size, right? Or that changes maybe in its characteristic properties, changing in the color or etc. things, right? Here simply the classification of changes here simply based on its physical and chemical properties. Mainly we can classify them into two categories. One is as physical change and the other is as a chemical change. So what are these physical changes here? Physical, externally, outside, right? So what we can see directly, they are called here physical. So a substance changes only in its appearance, or what appearance means, its color, shape, size, outline, only external view we can observe that, we can call it as here physical change. Example for the physical change, simply we can give ice turns into water. Just you keep ice cube in a glass in the open air for some time. What happens? Simply that ice can melt and its appearance completely changes. So that we can say here ice physical change. The next example is tearing of paper. So when you tear a paper, only its shape or size changes. But is there any change in the composition of the paper? No change. There is no change in the composition. So these type of changes are said to be here physical changes. Then the next one is chemical changes. So what are the chemical changes here? What are the chemical changes? Simply a new substance, completely different to the old substance. From it, it can give you complete characteristic properties differently with the change, right? So that are called here chemical changes. If new substances are formed with properties completely unlike, different, comparing with the original substance, so they are called here chemical changes. So we can give many examples for these chemical changes. For example, here digestion of food. So here what we are eating, it completely changes, convert. What the food swallowed by you, it goes to intestine and there something process is going on, then converted. So here energy is producing, right? Energy is producing completely the characteristic properties of the original substance after digestion that excrete have different. So this is chemical change. Few more examples we are able to say here. One is burning of crackers or burning of paper, burning of wood, anything, something burning. So that is what here chemical change. Why we are saying is chemical change? After burning of something, it remains as ash, releasing fumes, heat energy, light energy. So completely different characteristic properties substances are produced in burning of crackers. See, light, colors, then energy, heat, gases, and remains as ash. See here, completely they are different comparing with the original substances. So that we can say example for chemical change. The next process of respiration is one of the example for chemical change, because here breathing in air, yeah. So here breathing air inside, then after releasing that air, we can compare the percentages. Comparing the percentages, what they are here, amount of oxygen and amount of carbon dioxide. So that is utilized, and that oxygen combined with the blood, carbon dioxide collected and released. So the process of respiration is example for chemical change. Next example here, simply lime added to the water, lime powder added to the water. So when you touch the beaker, you can notice that change in the heat energy, and also you can observe that it's a nature changes. Water has something nature. After adding quick lime, that calcium oxide into the water, it can change its nature. Red litmus turns into blue. So basic nature adopted by the water. So new substance is formed in the water by adding quick lime. So that some new substance is calcium hydroxide. Next, ripening of banana. Will it be same? Comparing the product with that means after change, ripening. Will they remain same? No. It's a smell changes, right? Then nature changes. If you left for few days, what happens? Decomposition, right? So this is also one of the example for chemical changes. The next example, rusting of iron. All these are given in your textbook only. There are no new examples. All the textual examples only I'm giving you here. Rusting of iron nails. Suppose if you left a few new iron nails in the open air, what happens after a few days? They change, turns into brownish color. A powder-like structure will be observed on the surface of nails here. That is what? Rust. Chemically, it is iron oxide, Fe2O3, oxidation process. So this is what? Chemical change. So all these are what here? Simply they are permanent changes. So what we can say? Physical changes are temporary changes. Sometimes they are maybe permanent also. We cannot. For example, if I cut a tree, that wood cut into pieces, can you make it a reverse? No, it is not possible. Sometimes they may be permanent also, right? So physical changes, temporary or permanent. In chemical changes also, sometimes they are maybe chemical changes are temporary. We can reverse the process also. For example, what I told you here, fourth example, lime added to the water. So you can prepare lime water. If you blow air, carbon dioxide into the lime water, it can give you calcium carbonate and water separately. That calcium carbonate, it can take it and decompose. That calcium carbonate will give you calcium oxide and carbon dioxide again. So you will get again calcium oxide. Sometimes they are maybe temporary changes, chemical changes, sometimes maybe temporary changes. Then let us enter into our lesson here. First one is activity 1. So what is activity 1 here? Reaction of calcium oxide with the water. So to understand about this reaction of calcium oxide with the water, you required few materials. What the required materials are here? Calcium oxide, also called as quick lime, lime powder, calcium oxide, quick lime. Next, you required water, beaker or test tubes, then litmus papers to test the nature of the water. So distilled water you can collect first. No nature, right? Always, if you are finding the nature of some substances, compulsory, if you are dissolving that into the water, you can take distilled water. That is better for you. So here I collected materials. Then procedure. Take some water into a beaker, then add a quick lime. Small quantity of quick lime add into the water. Quick lime you can add into the water. Then what happens here? What happens? When you add quick lime into the water, simply it changes, turns into calcium hydroxide. Touch the beaker. when you touch the beaker, what you can notice? That means here we are touching to understand about the heat changes. So that heat changed or remains same, that you can understand. That you can understand. So here heat changes we may notice here. Heat changes we may notice. So here that heat changes we observe simply overcame. Here that beaker becomes hot. It becomes hot. So simply we noticing that heat changes. Then we have litmus papers. So introduce that litmus paper into the distilled water. Do you see any change in the color of litmus paper in distilled water? No. Red remains as red, blue remains as blue. Then use that same litmus paper to introduce into the lime water solution, calcium hydroxide, also called as clackled lime. Calcium hydroxide, lime water, or slackled lime. All these are for the same compound CaOH2. That names all for only one compound CaOH2. So here test the nature. It changes only red litmus into blue. Remaining blue litmus paper remains as blue. So what the nature? Here the nature of calcium hydroxide is noticed as simply basic. Red turns into blue, indicate us the nature of the substance is basic. So what are the observations here? Beaker becomes hot. That means its temperature rises, and that red litmus changed into blue color. So finally, what you can write the result? Becomes hot, and the nature of the substance also we can write red litmus changes to blue. So this is about activity 1. Next, activity 2. What is activity 2 here? Simply that reaction is observing between sodium hydroxide, sodium sulfate and barium chloride. Sodium sulfate and barium chloride. That reaction we are observing here. Simply for this, you required few materials. I mentioned already 2 chemicals, sodium sulfate and barium chloride. These are solid substances. So you can make it liquid solutions. How do you make liquid solutions? Simply adding water, dissolving that particular salt in the water. So we can call them as solutions. So prepare sodium sulfate solution and barium chloride solutions. Now here required materials, sodium sulfate, barium chloride, Na2SO4, mistake, Na2SO4 and BaCl2. Next here you are required beakers. You are required beakers or test tubes with water. Next, any other required here? These are enough. We are not finding the nature. Then what is your procedure here? Prepare first solutions, aqueous solution of sodium sulfate salt and barium chloride using water. So take a beaker, add water, then add sodium sulfate into one of the beaker, then dissolve it completely, keep one side. Then next take one more beaker with water, distilled water, add barium chloride salt into that, dissolve it completely, stir it. Then add one of the solution into the other using test tube or using a dropper or directly join it, no problem. Any method you can follow. So in the procedure, we are adding one of the solution into the other. Look at here. What happens when I add drop wise one of the solution into the other? You can observe that white color dense material separated at the beaker. So this is what here called as, this is simply we can call it ice. Undissolved material remained in the beaker of solutions called precipitate, right? We can call it as precipitate. So here simply that white colored dense material remained at the bottom is called precipitate. That precipitate in the reaction is barium sulfate. Precipitate in the reaction is barium sulfate. So what we can write the result here? White colored undissolved material is separated at the bottom, dissolved, undissolved, right? That white colored dense material is what? Simply we call that ice. Here it is precipitate. So white colored precipitate is formed. So this is about the result from the activity number 2. Then we'll go for activity number 3 here. What is activity 3 here? Observing the reaction of a metal with the acid or acid with the metal, whatever it may be. Simply here, not as acid given, directly zinc reaction with the HCl is given. In third lesson, we will learn the same activity as reaction of metal with the acid. Right? So understand well, it will be helpful in your third lesson also. Then what are the required materials here? Required materials are here zinc granules, hydrochloric acid. Then to transfer that acid, you require dropper, or you can use directly flask. In the conical flask, you can take some amount of HCl solution. Then you required one more matchbox here. Why? In this reaction, we will observe that gas is liberation of gas. Sir, how do you know directly? No problem. We don't know. You can perform it once, then realize what happened. Then again, conduct the same activity with the observations, adding some more in required materials, right? So in the procedure, simply we can take a test tube having liquid in it. Which liquid? HCl. So you can take a test tube with liquid, then drop a metal piece. Dropped. What happened? Observe. Bubbles are forming on the surface of a metal. That bubbles are indicating the reaction is taking place between the HCl and metal. Then bubbles in the liquid indicating the liberation of gas. So now you can test that gas. So here look at that gases are releasing. With the magnesium also you can perform this activity. That gases will be tested with a burning matchstick. Then what happens when you take burning matchstick near the liberated gas here? See here, orange colored or that yellow colored flame changed into blue colored, and also it can give you a pop sound. If a burning matchstick burns with a pop sound, that is indicating us the liberated gas is simply hydrogen gas. So gas is released. Observations are what? Gas is released, and burning matchstick burns with blue flame and gives pop sound. So these are the observations in the reaction. Burns with blue flame and giving you pop sound. If that burning matchstick burns with bright flame, no blue flame, bright flame, no sound, that is indicating us oxygen. If burning matchstick put off immediately, carbon dioxide. So 3 observations I am given for 3 different gases. Oxygen burns with bright flame, hydrogen burns with blue flame and gives you pop sound, carbon dioxide put off, fire extinguisher, right? So these are the observations from the activity number 3. Then here, after this, I'll give you about information simply about chemical reaction. So what you observed in the 3 activities. In the activity 1, new substance is formed, heat changes observed, and nature of the material also changed. Then in the second activity, I noticed precipitate is formed, completely different characteristic properties, 2 substances with 2 different liquids. In the third one, I observed new substance is formed and gas is evolved. So from this, I am able to say it is a process. It is a process that which takes place between 2 different substances, give you completely different characteristic properties to the new substance. So that process I am naming as chemical reaction. The process in which new substances are formed with the new properties are called a chemical reaction. This definition I am given based on the 3 activities results. It is a process that is taking place completely between new substances and giving you new products, completely taking between new products, right? So this is called a reaction. So here example for the chemical reactions are here. in our day-to-day life, what we are burning, that maybe your LPG gas also, not only this carbon, coal, paper, or something else. LPG, fuel, burning to cook food, right? So that is also example for chemical reaction. What happened in this actually, that carbon content reacting with the oxygen to produce carbon dioxide. Along with that, you are getting heat energy and light energy. That heat energy we are using for burning, sorry, for cooking. Burning process will give you heat and light. That heat energy we are utilizing for cooking. So here this carbon and oxygen which participating in that process, that are called here reactants. What we can call them? Reactants. So here this carbon dioxide, next here simply heat, light, what these are actually? These are said to be products. So that product may be one or more than one. What you can observe in the reaction, with that we can mention number of products and reactants in the result. So how do you define reactants? The substances which undergo change. For example, here carbon and oxygen together changing into carbon dioxide. So that substances which undergo chemical change called as here reactants. In a reaction that undergo change called reactants. Then here simply products. What are products here? After the change, which are remained with new characteristic properties in a chemical reaction are called products. The new substances produced as a result of chemical reaction called products. So we learned about a chemical reaction and what are reactants, what are products. Then here we observed some changes in the activities. What they are? 1, 2, 3 activities. So from that we are able to say in reaction what happens actually. What do we observe during chemical reaction? So during the chemical reaction, rearrangement takes place between atoms. Rearrangement takes place between the atoms. So that reacting substances, because of that rearrangement, they can form new substances with different properties. Right? So during a chemical reaction, rearrangement of elements or atoms takes place between the reacting substances called reactants here to form new substances having different properties. One, we observed that thing. Then here simply in any chemical reaction, any new atoms are produced or atoms combination is changed. Atoms combination only changed. No new atoms produced in it. Right? So here during a chemical reaction, simply atoms of one element do not change into another element, only its combination changes. Do not produce new elements. Any chemical reaction do not produce new elements, remember. Then in the reaction, right, in the reaction, here we may observe some changes as we noticed in the activity 1, 2, 3, right? So they are known as here chemical characteristics of chemical reaction, right? Characteristics of chemical reactions. So what they are here, characteristics of the chemical reactions are simply changes we noticed during the reaction only said to be here characteristics of the chemical reaction. What the changes you noticed in activity 1, 2, 3 or many other reactions also. So here new substances are formed. Yes, we know. New substances are formed, we know. Then heat energy changed. In the activity 1, we touched the beaker. In the activity 3 also you noticed that same thing. Contents becomes warm. Heat changes observed. Heat energy liberated or produced. Then here it may be absorbs the heat energy also. That contents may not always becomes hot. Sometimes they may become cool. So in that case, we can say heat energy is absorbed, or directly you may heat sometimes that contents using fire or flame, right? So that also we can notice. That reactions here we can mention as differently as thermal reactions, exothermic, endothermic, right? Next, here, simply in that maybe we observe formation of precipitate undissolved material in the activity number 2. In the activity 3, what we observed, gases evolved. It may release the gases also. Then here, some changes like a physical appearance changes, change in the color or shape or size of physical state changing, like that we may observe, right? So these are said to be here. One more is there, that is here, physical state. Not only the color, it's a physical change, mainly solid into liquid, liquid into gas, like that, right? So liquids converted into solid, that precipitate we named. So these are the characteristics of chemical reactions, right? Next, what is chemical equation here? What is chemical equation here? So chemical equation is very, very easy. Simply, it is a shorthand method that which we can represent the reaction using the symbols and formulas. So simply the definition of chemical reaction equation is given as, it is a representation or a process of representation for what? Of reaction, representation of reaction. So the process of representing of a reaction by using symbols and formulas called as chemical equation, right? Chemical equation is nothing, it is very simple to define, reaction representation using the symbols and formulas. A chemical equation also said to be, it is a shorthand method of representing the chemical reaction. Always you are need not to write the reaction. Carbon is reacting with the oxygen and producing the carbon dioxide. Along with that, it is liberating the heat energy and also gives you light energy. No need. Simply we can write C plus O2 mu is to CO2 plus heat and light. That is enough. We can understand everything from that. What are the reactants? What are the products? That always represented in the equation. That can be here reactants and products, that both are separated using a symbol called arrow. That arrow always directed to indicate the change, towards the change. Always the arrow is directed towards the change, right? Then here, examples for writing the chemical equation for a reaction. How to write a chemical equation? Simply that what the example we are discussed in the previous one, burning of coal in the presence of oxygen. So for that, simply I'm able to write a equation like this: carbon plus oxygen equal to carbon dioxide. So this type of representation is called a word equation. This type of representation is called a word equation. After that, for this reaction, word equation only, I can use the symbols and formulas for the compounds. It may be reactant or maybe the product. So what I can write, carbon and oxygen together, they are giving you. So that equal we can use as a symbol here, as arrow, indicating the change by the carbon and oxygen together, giving you carbon dioxide. So this is called chemical equation. This is called chemical equation. I think everyone got an idea what is chemical equation. Use your quick impression. Use your quick impression. If there is any doubt, everything is clear. Yeah. Okay. So now the topic is changed. Types of chemical equations. We know what is chemical equation. Now we are learning about the types of chemical equations. So here, types of chemical equations, this is very, very easy one. Identification, right? Type of reaction is different, but type of equation is very easy. Types of reactions means like a combination reaction or displacement reaction or double displacement reaction or exothermic reaction or endothermic reaction, electrolysis process, right? So many are there. So it is difficult, but identifying the type of chemical equation is very, very easy one. Simple. Here to identify the type of chemical equation, just we are depending on the count, right? Count of atoms on left side and on right side. Left side means reactant side, right side means product side. So left side to the arrow, right side to the arrow, like that you can see. So reactant side, product side, individually you can count the atoms. For example, here I am giving you the activity 1 equation. So calcium oxide adding into the water to produce lime water called calcium hydroxide. So counting the individual atoms in the reaction. So what are the individual atoms? Elements simply. Calcium is there, oxygen is there, hydrogen is there. So look at that. Everywhere, left side or maybe right side to the arrow, you can find these three only. Any other new element? No new element. So that is only we are given. No new atom or element is produced during the chemical change. Only its combination changes, right? So here you can make a table. You can make a table as you see here. So three elements I counted, one more adding extra. Then these four are taken as rows, then three columns, right? Number of rows depending on the number of elements and one extra added. So atoms count, individual atoms plus one, that many as rows. Then columns always three. Then note down as atom. Next, number of atoms in reactants, number of atoms in products. Then atoms, already we know three elements are there: calcium, oxygen, and hydrogen. Okay, noted. Next, counting left side and right side. Left side and right side. So first, left side, reactant side, calcium. How many atoms are there in these? Only at one place and not repeated anywhere on left side. So we can take the count of calcium as 1 here. While you are writing the count, see the coefficient and subscript. What is coefficient? What is subscript? Suppose here 2 O2 is there. So this 2 is coefficient, this 2 is subscript. If nothing is there, O, it is an atom. O2 is molecule. This you learned in a 9th class. Difference between atom and molecule, right? So this is about the count. So now I am written count. The next here, calcium completed. Oxygen, left side 2, because 1 is there in calcium oxide and in H2O. So both together 2. Hydrogen, only in H2O, that is 2. Subscript is there. Then right side, calcium, only at one place, no subscript, no coefficient, 1. Next, oxygen 2, bracket, distributive property. Next, hydrogen 2. So count of that atoms are completed. So this time also completed. Join immediately using the same link. Join immediately.